maybe a glimpse of power sector is really important, and इंडिया की ग्रोथ स्टोरी पे जो बिलीव करता है they might be able to appreciate the numbers how India is growing in terms of electricity. So the CAGR rate for the growth has been around 5% since last 10 years. Per capita consumption, if you see, it was around 1000 uh, kilowatt hour, and now it is around 1400 uh, kilowatt hour. So that is a significant 5% growth year on year basis in the per capita consumption. At the right hand side, you can see the kind of energy mix which we have. I guess, can I hide this particular bar somewhere?
Sir,
So
we can see only you, for you that is a this one we can
that
see it
is
well.
easy. Okay, thanks, great. So on the right hand side, you can see the changing energy mix. So what does it mean? At one point, there is a rising demand, and on the other point, the electricity or the energy mix of India is changing. At one point of time, we had a high capacity of coal, but now you can see the new candidate, which was cheaper, also the renewables, they are started emerging and taking a lion's share. As on now, we are at 480 gigawatt of installed capacity, with 45% being contributed by renewables and hydro. What exactly these numbers or this particular slide signifies that nation is improving its quality of life for its citizens and powering its economic engine. Why this growth has happened in terms of demand and electricity is that there has been a significant shift towards urbanization. Initiatives like reliable power that should reach every household in the rural area has been one of the massive thing which has led to the electrification. And we also have seen switch to transportation, switch in the transportation where from ICE to mobility, e-mobility is something which is significantly gaining that traction. This shift from towards renewable energy is also important because this helps India to become more energy secure. But it also comes with its own challenges. That is, the electricity is now intermittent variable, but that has to be managed because at the end of the day, if we are able to become energy independent and rely less on the oil or other forms of energy which we are importing, that will definitely help us to power our progress faster and better and in a more sustainable manner. So, if I talk from the trends, why is artificial intelligence key for electricity grids? I have five things in my mind that really are making that transformation happening. Number one is rising demand that we can see and the changing geopolitics. Now, the second part of this sentence, the geopolitics is really important. I mean, if you see today, uh, governments want to attract AI companies, and by definition, that means that they are attracting data centers that go with that. And for this, what we need is electricity and water. It also means that off-grid energy solutions that are combining with energy data centers where energy is produced and generated off-site to deliver to the data centers are going to become increasingly important. Now, as you can see, there has been a rapid change in energy mix. There is a surge of distributed energy resources. Most of the entities, I mean, most of behind the meter that we say are now having solar or some form of uh, generation that is managed by themselves. What it actually signify that when there was initially a monopoly business of a utility, which is now getting a beating in the sense that uh, there is a prosumer who is consuming as well as producing, and that surge is going to happen more and more as the economics start helping them. So this rapidly changing energy mix where you have different forms of energy, different forms of generation is going to play a major role. Uh, while demand is rising, AI can actually help to identify cleaner forms of energy mix, and that is where the role of AI becomes more prominent. Third point, that is aging infrastructure. So the utility network, which was built in past, was never meant for bidirectional flow of information and electricity. It has always been uh, mono uh, monodirectional or unidirectional. Now this is actually taking a beating because first of all there is the energy mix that is changing from it's getting bidirectional. Second is kind of extreme weather events that also is impacting. So if you can predict early, then you can save or you can identify where the things are going to be critical. The impact will be critical, and that infrastructure can be protected. The fourth point is cost prohibitive manual methods. So traditionally, I remember when I mean working in transmission sector, I mean, we used to do surveys using helicopters. Now, this traditional helicopter survey and foot patrol used to cost 1 lakh rupees per kilometer with limited coverage. Now, with AI drone technologies, this inspection cost has reduced to 50% and also reduced man hours. So, that kind of impact is what AI is bringing, and we will see some of those examples, real life examples, as I go into my next slides. And finally, efficiency and time matters in an increasing competitive environment. I mean, earlier there was a monolithic approach where once you have a utility, you are a monopoly. But now, with rising privatization, whosoever have early information find chances to improve his competitiveness more. Other data point which I wanted to add, and that is more from the distribution side, is that cost of power procurement is the biggest cost for utilities. And if you are able to have much more better information in terms of forecasting, in terms of analytics, you are more confident and can make quick decisions about which resource to procure at what cost. And that definitely changes the entire game. So, having said that, uh, there are many use cases which exist on the ground where AI is really contributing significantly. But for the sake of this discussion, I have identified 6 use cases which actually have proved really very helpful. And these are the lessons from the ground which I am going to discuss now. These 6 use cases are to the tune of inspections, how they are being done in transmission and distribution, how substations are monitored through AI-driven optimizers, how assets like solar and wind are managed, how smart meter data is being evaluated using AI agents and engines, the distribution transformer health, and finally, the most important piece for any uh, cash-driven utilities, customer engagements, and outage management. So how AI does that? So whatever I'm going to present are actually real life examples, which I have taken from my previous experiences on different projects. So the first case I would like to discuss is about transmission and distribution inspections where drones are getting used. I mean, for transmission sector, it was a no-brainer. You have long lengths of lines, you have to go for petrol. Drone proved to be a very successful technology. But when we started discussing the distribution sector, which is dense populated with so many consumers in small pockets, there was a significant apprehension in the utilities that how will it happen and whether it will be successful or not. But what we have realized is that the kind of impact it has been able to provide, I mean, in terms of reducing the losses, is phenomenal. Uh, these are the actual images from one of the utility with whom I worked. I mean, drone was able to actually detect the theft because once it started doing the rounds at different intervals of time, people were looking, and you can see in the first image how drone was able to capture the image and keep it provided to the lineman. In the second image, if you can see, let me see if I can, yeah, if you can see, there is a small box which mentions about the insulator cracking. So generally what happens if an insulator gets cracked, corona discharge occurs and the system or the line goes for an outage. Now, once a person goes through a manual inspection, he is not able to see standing down that what exactly is happening on these insulators. So these minor crackings at what pole, where exactly, how much is the severity, all these images were getting captured and immediately AI was able to tell what exactly is the index, severity index around it. The condition of wires and the lines which are not visible to the naked eyes, or any critical faults where, so for example, joint is not properly put, the workmanship is poor. I mean, this actually has helped utilities to significantly reduce the cost up to the tune of 30 to 50%. What it also meant was AI drones and the inspections done was able to reduce hazardous climbs by 40%. They proved to be more accurate. I mean, 92% and more. It was able to achieve on insulators and detect what exactly, how is the status with respect to the benchmarks. The loss reduction was around 1.5% of AT&C loss, where we say technical and commercial. Commercial comes with the theft and all, while technical comes with the problem with the infrastructure. That was recorded in the first year itself. And the payback was almost within 2 years. The payback was there with analytics. They were 5 times faster than the manual reviews. So these were significant things. I mean, for any utility, if they have started doing, and one of the example was a state utility who did that. They really found this so helpful that generally now what they do before any festive occasion or before any particular change of weather, they do one survey through drones so that they can understand the health of their infrastructure, and if something requires any change, at least they know which transformer is more critical or which line is more critical and that has to be mended properly. So this has reduced considerably the workman hours. And second important thing is for any utility, their business is basically selling electricity. So if they are reducing the downtime, that is where they are earning. So this definitely, this technology driven by AI, where image capture is happening and that image is getting analyzed, proved significantly helpful for all those utilities, especially in distribution sector as well. The second use case is about renewable assets. I mean, this is where it is very important and interesting to understand that renewable energy farms like solar or wind, they cannot compromise meeting the commitment as they are the independent power producers and they have the power purchase agreements generally they sign have severe penalties if they are not able to meet the capacities. So generally a hotspot, if it happens, it takes a lot of time because it has been seen that drone to drone around 900,000 modules were one of the company was able to inspect in 5 days, which was earlier taking 2 months in the manual inspection. And such kind of imaging has actually been able to flag dangerous hotspots. And hotspots, how they form, sometimes it is birds dropping, sometimes some localized issue has happened where there is a manufacturing defect or any leak fall. So those dangerous hotspots, they were able to identify and immediately the crew was sent to amend it. And the same thing like in wind farms, the thermal imaging, generally this is what where you basically see the blades, how they are performing, if there is any small cracks that are being developed. I mean, that is what they were able to do. And the rope access inspection, which generally accounts for 1% of wind farm operational expenditure. In fact, one third of that is what now these technologies are costing. So they have proved to be really helpful for all those IPPs who have put their solar and wind farms. And naturally, they have reduced the manpower cost as well as the overall inspection and maintenance. Another use case which I found really insightful was smart metering data. I mean, India has a very big target, ambitious target of 250 million smart meters through RDSS. And the amount of data which these smart meters are going to generate is phenomenal. Now, what has happened to this data, how AI has supported in inspections of this data is very, very interesting. I'll take a couple of examples. Like uh, there are there are um, there are like households where people are generally running some kind of coaching center. Now they generally keep two meters, and it is like multimeter. One is domestic, another is commercial. But at some places, what we have found was there was a tariff misuse or the subsidy misuse. Now with AI, the disaggregation, it was very when the data was disaggregated, it was very clear that some uh, some elements were actually switching those meters. I mean, that is what the power of AI was, that they were able to detect, not only detect, they were able to tell at what time you should go for inspection to have that kind of evidence available. So that kind of analytics is now very much possible. Industry is the cash cow for all utilities. I mean, industry tariff is higher. Normally, we utility ensure that for industries there is no challenge or there is no deficiency left to provide them the services. So if there is any early signal, warning like CT is missing, current transformer, or some detection, that detection can be early and the faults can be detected in advance. So that is what helps them to understand that for this particular industry, we can go early and take care of them. At some places, the meters have provided last gasp feature where before saying that, okay, I am going to die out because of some XYZ reasons, those events have got logged, and meter burn can be one of the cases, any tampering. So these cases have also been logged. So this data actually has helped us to understand the typical consumption pattern, detect any theft, misuse, and disaggregation at the appliance level. Also, what it did was, I mean, AI, what specifically one of the use cases that has emerged really well for utilities, the customer engagement. So, generally, what happens at distribution and the customer is one of the key stakeholder, but often neglected. Whenever there is a loss of supply, then only there is a huge furor, and then utility starts reacting to it. But now with AI, proactive engagement has happened. For example, if there is a high bill, then there is a the volume of high bill calls have reduced, because now utilities are able to provide customers with timely bill shock warnings and tips to manage their usage. The customer engagement has improved because certain utilities have the analytics capabilities where they can disaggregate the data to understand which appliance actually is contributing to the load, providing them the monthly usage statement and also telling them that, okay, you can change this appliance from 3 star to 5 star, it will reduce so much of energy usage. Utilities have also increasingly started focusing, because they understand the model is changing. If they can provide any value add service, the consumer will be retained. And if any utility has found that this customer load is getting increased for some reason, or he has higher propensity to pay, they have through the data started providing recommendations of rooftop solar installation or going for purchase of energy efficient appliances or EV charging. So these capabilities generally which utility is not able to provide because of short-term casualties where they kind mostly focus on, are now becoming easier and more manageable through artificial intelligence and the solutions which are there in the market. Seen that the insulation or any overload, overheating is where AI have played a major role. The intelligent response system has actually triggered cooling fans and also provided a dashboard that ranks transformers by failure risk with GIS guiding the crew rating. So these are significant advancements, and this is my last slide where I see I can just mention certain challenges and certain things which needs to be uh, taken care as we move forward. First of all is the bottlenecks. I mean, SCADA, RTU, and uh, they actually are outdated, old, and they limit the real-time data. So if we are able to uh, have some updates around it, that will be really very helpful. There is a skill shortage, definitely. We need to have a cadre of security specialists, AI specialists now in the utilities, and also the regulations around it. The way forward, I see important part is having a roadmap, which utilities need to build, and have some KPIs that helps them to continuously track. And also, not all use cases are very strong and will provide them ROI. Identify two, three use cases which really are going to prove very, very helpful, and then move forward with them, make them integral part, and then move to others.